In this video, I'm going to present you a few exam-style examples using questions from past IB questions. We're going to start with this paper 2 question. Find the gradient of the tangent to the curve x power 3 y power 2 equals cosine of pi y at the point -1, 1. So what we have to do is differentiate implicitly this expression, solve for y dash, or the derivative of y, and evaluate the derivative at the point -1, 1. So let's begin by finding the derivatives. So the derivative with respect to x of the left hand side equals the derivative with respect to x of the right hand side. Now in the left hand side we can see that this is a product, so we are going to have to use the product rule. So that is the derivative with respect to x of x power 3 times y squared plus x power 3 times the derivative with respect to x of y power 2 equals, and the right hand side is a composition. So the derivative of a composition, we need to use chain rule. So this should be minus sine of pi y times the derivative of the argument pi y, which is pi y dash. The derivative of x power 3, going back to the left hand side, is 3x squared times y squared plus x power 3, and the derivative of y squared is 2y y dash, and that should be equal to minus pi y dash sine of pi y. There is y dash on both the left hand side and the right hand side. So what I want to do now is make sure those two terms that contain y dash are at the same side of the equation. So I'm going to keep those to the left and the terms without y dash to the right. So I should have 2x power 3 y y dash plus pi y dash sine of pi y equals minus 3x squared y squared. Now taking y dash out as common factor, and finally we're going to move these parentheses to the right hand side to get y dash equals minus 3x squared y squared, everything over 2x power 3y plus pi sine of pi y. Now the question is asking us to evaluate the gradient of the tangent to this curve, so we need to calculate the actual value of the derivative. So we're going to substitute the values of x equals to -1 and y equals to 1 to get y dash at 1. That would be equal to minus 3 times -1 squared times 1 squared over 2 times -1 power 3 times 1 plus pi sine of pi times 1, and pi times 1 is pi, sine of pi is 0, so we know this is going to be 0. The top is going to be 3 and the bottom is going to be -2. So the final answer is the gradient is -3/2. Example number 2 is a paper 1 question. The normal to the curve x e to the power of -x plus e power x equals 1 plus x at the point c, natural logarithm of c has a y-intercept equal to c squared plus 1. Determine the value of c. So for this question, the first thing we need to find is the derivative of the function, and we're going to do that on both sides. Because this is the normal function, we not only need to solve then for y dash, but we need to take the negative reciprocal of it because it is perpendicular to the tangent. It's not the gradient of the tangent itself. So once we have the slope of the normal line, we can find the equation of the line, and with the information that the y-intercept is given by this amount and that the function goes through this point, we should be able to find the value of c. So let's begin the question by taking the derivative on both sides. So we're going to start. Left hand side is derivative with respect to x of x e power minus y plus e power y equals to the right hand side, which is derivative with respect to x of 1 plus x. Now the right hand side is fairly simple. The derivative of 1 plus x is 1. And in the left hand side we have a product plus e power y. So we have to use product rule and chain rule for the first term and chain rule for the second term. Let's begin with the product rule. So derivative with respect to x of x times e power minus y plus x derivative with respect to x of e power minus y, and then plus the derivative of e power y, derivative with respect to x of e power y. And this should be equal to 1. The derivative of x is 1, so the first term is e power minus y, plus the second term should be x, derivative of e power minus y. That is going to be e power minus y times the derivative of minus y, which is minus y dash, and then plus the derivative of e power y is e power y times the derivative of y, and that should be equal to 1. Now we get two terms that have y dash and one that doesn't, so we're going to move the term that does not contain y dash to the right hand side and take y dash as common factor out of the expression in the left hand side. So y dash common factor of x e power minus y negative plus e power y equals 1 minus e power minus y. So y dash is equal to 1 minus e power minus y over e power y minus x e power minus y. Now in order to find the slope of the normal line, we need to find the slope of the tangent line, and we're going to do that by substituting the point c ln c into this expression. One thing we need to remember is that e and e power x, one thing we need to remember is that e power x and ln of x are inverse functions to each other, so when they are in a composition, they cancel out and only the argument of the composition remains. So in the case of the exponential, we need to remember that e to the power of ln c is going to be equal to c, and e to the power of minus ln c is going to be c to the power of minus 1 or 1 over c. So doing the substitution, y dash evaluated at the point c is going to be. Now to find the slope of the normal line, we need to take the reciprocal negative of this gradient. So the slope of the normal line is going to be m equals 2 minus c. And the equation of that line is going to be minus cx plus b, where b is the y-intercept of the expression. So that should be c squared plus 1. So this is the equation of the normal line. Now in order to find the value of c, I know that this line has to go through the point c ln c. So I'm going to substitute that, and we find the final value of c equals to e.